So in this brief video, we're going to talk about some of the aspects involved in presenting your research problem. And this includes choosing a title, writing your introduction, stating your research problem and hypothesis, identifying the variables that operationally define that research problem and hypothesis, and most importantly, justifying why the study should be done in the first place. So choosing the title, I typically recommend waiting till you've completed the study, or at least completed the proposal for your study. Reason being is you got to be able to describe it. The title should appropriately and accurately describe the focus of your research study, and sometimes you don't know what that focus is until you've completed the majority of the work in your research study, and sometimes that's even until you get to the results and discussion, right? So think of it as writing a story, and you write all the storyline, the various chapters, and sometimes you can't wait till the end until you describe or come up with a title that accurately describes that story. Same with a research study. You kind of have an idea of what you'll be studying, and you definitely should have a research problem and hypothesis defined that you're ultimately going to be proposing and testing, but you don't know the significance of that study until you've looked at the results and formulate your discussions and see how that links up to previous research. So I would wait on coming up with a title. We want to come up with a title, as I mentioned, that accurately conveys the focus of the study, that's not too wordy and also not too short, that it does not accurately describe the focus of your study. So don't worry about that for now. But an important section of your study, and more specifically, if you're taking research methods with me, the introduction is the heart, along with the methods, the heart of your research proposal. So you're ultimately going to propose a research study to your peers and to your committee, and where you sell that study is in the introduction. It should catch the reader's attention right away, because you're showing the clinical significance of the study, the research questions that you hope to address, and what your hypothesis all go into the introduction. And the first part of the introduction is typically the background on which your study is based. So this, you can talk about injury risk or athletic performance, whatever that may be. And so in a way, it should sell the clinical relevance and implications of the study, whatever it is that you plan on studying for your thesis and a capstone. You should always identify any gaps of knowledge in the literature, because that ultimately justifies why you're doing the study in the first place. You're addressing a research question that was not previously addressed in the current literature, at least what's reported in the current literature. So it also usually concludes with the statement of research purpose or research problem, as well as you as a researcher's hypotheses, what you believe is going to happen. So what's included in the background? A review of the current literature. And the length of the background largely depends on the type of manuscript that you're writing, whether it's a dissertation, a thesis, capstone, or journal article. Typically the dissertation and the thesis tend to be longer, more detailed. You typically would work with your committee members, your faculty advisors, who will guide you on how much details you should include in your review of literature. But ultimately, if you plan on submitting this to a journal, the background and lit review itself typically has to be condensed. Usually have to be trimmed, and sometimes it's more challenging to trim that down than it is to write the discussion. The background itself, the lit review itself. So for now, you want to include as much detail as possible in your lit review, and then if you cross that bridge where we're in a position to submit this to a peer-reviewed journal, then we can discuss how, or some of the ways that we can trim that down. Okay, relevance. This is an important aspect of research study. Why should you do the study in the first place? Can the results of your study be generalized to the population from which your sample was drawn? Case in point, if you're a sports medicine professional, an AT, a physical therapist, an OT, and a PA, typically we address certain problems that we see in clinical practice, whether it's using a new test to indicate, to find injury risk, for example, or a new modifiable risk factor that you found in the lab, and be able to use that in clinical practice. So it has to have clinical relevance, and typically that involves either measuring some level of risk in different types of injury, whether it's a modifiable risk factor or another inherent risk factor that's involved with certain populations, or it has to do with athletic performance. So usually you draw this from your own experience, you induce these hypotheses from your own experience, or you logically deduce from existing theories. So in any case, the research study that you hope to propose needs to have good clinical relevance. So let's look at an example here. In the next few slides, I'll bring out sections, or I'll show sections from a research proposal that was presented a few years ago from a student that was performing a thesis project. So she was interested in looking at running mechanics, specifically in transfemoral amputees. These are amputees, or individuals who have amputations above the knee, so they have a prosthetic knee as well as a prosthetic foot. So in the first part of her introduction, she's making a case on why lower limb biomechanics during running is an important indicator that obviously defines injury risk and performance. So I highlighted a few statements here. From a biomechanical standpoint, running is a complex process that is still not fully understood from a performance and injury prevention perspective. So it's just making a case that, well, there's some work that still needs to be done here. A better understanding of running mechanics with regards to lower limb amputation in conjunction with what is still being investigated about able-bodied running mechanics can benefit these individuals in the application of rehab programs. So it's just focusing on these individuals with amputations, little is understood on their specific running mechanics, and the data that she, at the time, she hoped to collect and test her hypothesis may benefit these individuals in terms of training and rehab, and could potentially mitigate future clinical problems and facilitate optimal function. So every good introduction should start off with a kind of a broad statement of the activity in which you hope to examine, and discuss potential benefits of your research in conjunction of what's already out there in the current literature. So that is the clinical relevance. Okay, then it leads into the gaps in the literature. It's very important that the introduction conveys, obviously what's already been published, but also what research questions remain, and this is what we call gaps in knowledge in the literature. So let's take a look here. This is, I fast forward a little bit towards the end of her introduction. Let's see, so she makes the case of collecting lower body kinematics and ground reaction force during running in individuals with amputations. However, there is limited data, if any, that investigates the potential relationship between what she was looking at. She was comparing foot strike patterns, rear foot strikers versus forefoot strikers in these individuals, and as well as able-bodied individuals. And there's limited data to indicate a relationship between running biomechanics and these foot strike patterns. So she's making the case here on why she should be doing the study in the first place. While a previous study showed improvements in limb symmetry, knee kinetics, impact ground reaction force with a foot strike pattern, the design was a single subject case studying measuring effectiveness. Here she's saying that yes, someone looked at it, but it was only a single case study. So no one has actually drawn a sample from this population and looked at it from a more broader sense, so they can run a statistical analysis. Aside from that case study, she says that no data regarding foot strike patterns in runners with amputation has been reported or made available. Automatically, she's making another case on why she should do her study based on the research questions that remain in the current literature. So this leads to her statement of problem. So that this statement of problem should always follow the statements in the gaps in the literature in that section. So the problem statement really is just the purpose. It's the purpose of your research study and why you're doing it, what you hope to achieve, what is the aim or purpose of this study. So it addresses the problem statement. As I mentioned earlier, it should always follow the statements of gaps in the knowledge in the literature. So another word that's typically described the research problem is the research questions that you hope to answer in your study. So going back to that study I just showed you, she the paragraph immediately following that section that included those gaps of literature, it includes the purpose. So the purpose of this study, remember this is a proposal, this future study is to investigate the foot strike patterns of runners with amputation in conjunction with ground reaction forces and lower extremity biomechanics to explain potential asymmetries. It's detail is also somewhat broad because we don't know what exactly is lower extremity biomechanics, and I explain it later when I talk about variables and what that means. But notice here is one statement of the research problem. She hopes to investigate the effects of foot strike patterns, and more specifically rear foot versus forefoot, on just say generally lower extremity biomechanics during running. Right? So that's statement of problem, raise a question, and then she goes on to talk about her hypothesis, which I'll go into in a sec here. So when you got your problem, when you're talking about hypothesis, these statements need to be clear, and if you're talking about the hypothesis, they need to be testable and measurable. Actually, I got that backwards. They need to be measurable and testable. That means the variables that were collected need to operationally define her research question. In this case, lower extremity biomechanics between rear foot strikers and forefoot strikers. Talk about the limitations and delimitations. These are possible shortcomings. Maybe she's just concentrating on a specific group with a specific type of prosthetic. So it's best to be upfront with these limitations and delimitations. Typically, these are included in the discussion later on after the study has been done. And again, make another statement of why the study is important, why the potential benefits of this research would be a good thing for the general population in this case, or I should say the general population from which her sample or your sample eventually is drawn. Cool. So before we talk about these hypotheses, I wanted to give a quick review on the different types of variables. And if you've taken, my undergrad stats course or any stats course or research methods course, a lot of these terms should be familiar to you. So an independent variable is explanatory in nature. It's also typically categorical, or where they categorize by groups. The dependent variable is the response variable. That's typically your outcome measure that operationally defines, as I mentioned earlier, your hypothesis and research question. A control variable is a type of blocking variable. It's typically group this by sex, by age, by competitive level, where it's not included as an independent variable, but perhaps could influence the data. For example, if we're looking at ACL injuries, and we know based on current research that the incidence of ACL injuries in female athletes is higher than it is in male athletes. So if I'm running a study, I would control for that variable of sex and say, I'm just going to concentrate on female athletes in this study. So that's a type of control variable. Extraneous variable is a covariate that you included, perhaps or not addressed as an independent variable, but could potentially influence the relationship between your independent variable and your dependent variable. Age and sex could be one. So let's just say I included everybody in my collegiate population because I was concerned about sample size. So I have age and sex in looking at, neuromuscular training and ACL injury risk. So we know that age and potentially, we know that sex and potentially age could influence that data, so we could include that as a covariate. And so that's called an extraneous variable. And there are statistical ways in which we can account for the variance due to that variable. I explained that in a separate lecture. But that is one in which that variable is not included as an actual independent variable where you as a researcher manipulates or controls. Okay, so now that we have identified those variables, we can then lead into the hypothesis. And in this study, the proposal that I mentioned earlier, this is the same study, the overall hypothesis is that rear foot strike pattern utilized by the intact limb. So the rear foot striker was compared to the forefoot strike pattern. So that is the independent variable. Remember, she's looking at rear foot versus forefoot. And then here, knee flexion at initial contact, impact transient force, ground reaction force, peak ground reaction force, and increased average loading rate. Those are all the dependent variables by which her research problem and hypothesis are operationally defined. Let's see here, as compared rear foot striking residual limb as compared to able-bodied runner. So another independent variable was comparing amputees versus able-bodied runners. So she had actually two independent factors in this particular study. But notice she was detailed. She detailed her dependent variables, her independent variables as shown here, which is Rifford versus foot strikers, as well as the amputees versus able-bodied runners. Can you guess a control variable in here? Well, I mean, one of them is age, but she didn't mention it specifically in here, but she did mention it in her methods. Another one you can argue, at least for the first independent variable, would perhaps be the amputees. You're only looking at transfemoral amputees as opposed to transtibial amputees. So it's above knee versus below knee. So that is a type of control variable. If she says she's only looking at female athletes, sex in this case would be a control variable. So anyway, this is where you would indicate those limitations in terms of your research question. An analogy that I typically like to use is evidence-based practice. If you're taking an EBB class, you usually have to come up with what's called a PICO question. PICO stands for patients, intervention, control, and outcome. And the intervention could be your independent variable, the intervention versus control. The O, the outcome measure, is your dependent variable, and the P, which is the patient group, is the control variable. You're looking at female athletes who have a history of ACL injury. I don't know. That is a form of control variable. So anyway, PICO is a perfect example of how to illustrate each one of these variables in one statement. Okay, so now we've identified the variables. Now let's talk about the different types of hypotheses. Again, if you've taken research methods or a stats course, a lot of these terms will be very familiar to you. So the null hypothesis, every inferential statistical analysis, or I should say hypothesis-driven research, has a null hypothesis. And I go over this in detail in terms of the variance in a separate lecture on significance testing. So null hypothesis simply means that there is no relationship between your variables, or that there is no difference between groups. Okay, so that's the null. Just think about the word null, right? That means nothing or none. In this case, there's always going to be a null hypothesis in your research study. It's your job to state what that null hypothesis is. Okay. The alternative hypothesis is the exact opposite. You're saying that there is going to be a relationship, or that there is going to be a difference between groups in your dependent variables. And there are two types of alternative hypothesis. One is called directional, where you believe that the difference is going to be one way or the other. It's going to increase, it's going to be decrease, or there's going to be a positive or negative correlation between variables. Whereas a non-directional hypothesis is one in which you're just saying there's going to be a difference, one way or the other. We're not sure. Or that it's going to increase or decrease, but prior to stating our hypothesis, we're not sure, or I'm sorry, prior to testing that hypothesis, we don't know whether it's going to be higher or lower. That is called a non-directional hypothesis. And typically you would state a non-directional hypothesis if you're looking at something new, if you're looking at a new intervention, or if you're looking at a new diet, and you know that's going to be a difference, but you don't know if it's going to improve or worsen, right? So your hypothesis said, we hypothesize that there's going to be a difference in knee valgus torque after 8 weeks of HIIT. We don't know whether or not it's going to be higher or lower. Right? So that is an example of a non-directional hypothesis. So when you're developing your research hypothesis, a lot of it has to do with what you believe in prior to doing your study, and a lot of it has to do with the existing theory and current findings in the literature. And oftentimes it's the research hypothesis is the alternative hypothesis. You believe something's going to improve or something's going to change, or you can be the other way around. You can believe in the null hypothesis. There are perhaps a group who believe that it doesn't matter what shoe you're wearing. If you're an elite runner, you're going to have the same time or the same performance regardless if you wear Nike, Adidas, or Hoka's, whatever. That is an example of a researcher who believes in a null hypothesis, or they can believe in the alternative. So it depends on what you believe in coming in. You'll sit down with your faculty advisor or your committee and discuss that null hypothesis versus the alternative hypothesis, and you as a researcher would state which one you particularly would believe in. But in any case, when you run the research study, it's all about the probability of observing this null hypothesis in your study, and whether or not that you reject it or fail to reject it. Anyway, that's a different lecture altogether. Okay, so coming back to our example research proposal here, let's take a look at her hypotheses. It is hypothesized that the intact limb would generate decreased knee flexion at initial contact, impact transient of vertical ground reaction force, increased peak vertical ground reaction force, and increased average loading rate. So based on this statement of a hypothesis, is this a null hypothesis, directional, non-directional? Good. So you can see here she mentioned decreased knee flexion, impact transient vertical ground reaction for increased vertical ground reaction for increased averaging load rate. So obviously her hypothesis is directional. She believes that it's going to change in this certain direction, as compared to the rear foot striking residual limb, while only showing differences in peak vertical ground reaction compared to rear foot striking able-bodied runners, as previously been reported. So this last part of it, and she mentioned multiple dependent variables here, but this is a different hypothesis because she's talking about now the influence of the other independent variable, which is able-bodied versus amputees, and she's showing, while only showing differences in peak vertical ground reaction force, there's no direction there. So that is a non-directional hypothesis.